Welcome back to another episode of LINAK's Anatomy of Actuation video series. I'm Hunter Stevenson.
And I'm Anthony Fossiluzza.
And today we're going to talk a little bit about the BusLink software that LINAK has for all of our integrated controller actuators, like this one, which is an IC advanced actuator. We're going to use BusLink software right now, and we're going to kind of give you an idea of how to go ahead and connect it to the software itself. Take a look at some of the features behind it and how to change some of the settings internal to the actuator itself, and teach you a little bit about the behavior behind it and how to service it if you need to.
So first things first, Hunter, can you please open up the software?
Got it.
So we're going to move our cable lock back, attach our USB cable to the actuator. Then we're going to apply power. And the order of this operation is important.
That's right. You'll notice it just connected up, but we're noticing that the position says not available, and we want to make sure that gets calibrated right away.
So one way we can do it is we'll go to the service tab, and then the actuator, to get calibrated, all it needs to do is run out and then hit its limit switch. So you can do it in the outward, fully extended position, or we can just run out a little bit and then come back in. So I think that's what we're going to do.
Yeah, so I click the calibrate tab here on the left side of the screen, and I'm going to click initialize out. All I need to go is a little bit out and then right back in to get it calibrated. You'll notice that little error down at the bottom that where it said it didn't know the position is now a green check mark, saying that we do have the position accurate now. So now we're going to go ahead and talk about this control center down at the bottom of the screen. Now this is always viewable in BusLink, no matter what tab you're on up here. You're always going to see that down here. So what does that do? You have the options to run out the actuator. If I want to run it out, you can run in, and you can stop it directly from there. Really just for diagnosis and just for testing the actuator when it's in IC. You also have the ability to do step outs. So say I wanted to just do a step of 100 millimeters. I just typed in 100 and I'm going to press enter and step out. It's only going to step out that much distance. We also have the ability to run to, if I want to run to a specific position along the stroke length. And you can also see how much current's being consumed and the voltage that's being ran into the actuator. And LINAK made a lot of really neat features in here that go even beyond just being able to set speed or current limiting, and we'll talk about those now. So from the configure tab at the top, we have our first option is overview, which actually gives us an idea of what all those parameters have been set to. But the second option is virtual limits, which is the first of those parameters. Virtual limits is really neat because you can set the stroke length of the actuator. So here I've actually set the virtual limit out to be 100 millimeters and the virtual limit in to be 0 millimeters, which means the actuator in normal run, if you're just giving it signals, will only ever run 0 to 100 millimeters. It won't run outside of that, which is really great for prototyping purposes. And then we have current limits, which you can set from within. You can do a current limit outwards and a current limit inwards. So you can change that. That can actually be different. So say your pulling force, you want to be a lot higher and not have a cutoff as much as maybe your pushing force. And you can set those here based on the amperage rating.
And that's good for if you're trying to protect something from crushing. Say it's a push application.
Yeah.
So as it's coming down, you don't need the current limit to be very high coming inward.
That's right. You can cause damage, if you don't set these limits, and it could also cause harm. So it's really great to be able to adjust these from within the software. We also have the option to set speed, just setting it as a percentage of the full speed that the actuator is capable of. And then you have something that's really neat called soft start and stop. This helps extend the life of the actuator by allowing the actuator to slowly ramp up to full speed or slowly slow down from full speed. So when a signal is let off the actuator, it'll slow down to a complete stop. And when a signal is applied to the actuator, it'll slowly ramp up to the full speed. So there's never to apply any jerk to the motor itself. We also have the feedback option where you can set it. So right now it's set to no feedback, but we can go ahead and select from here. Say I want it to be voltage feedback, where I can actually choose a voltage for the minimum and the maximum. That would correspond to 100% and 0% of the stroke length. It is also nice to note that this voltage feedback within BusLink and our integrated controller actuators, they scale with the stroke itself. So say I did set that virtual limit to be 0 and 100 millimeters, that 0 to 10 volt feedback is going to scale to that 0 to 100 millimeter stroke, which is a really nice feature to have. And then at the very bottom you have utilities, which tell you kind of what you're about to apply, and you can click apply right there to save those new features like the feedback we just set.
And anytime you add a new parameter to the actuator, it does need to be recalibrated.
That's right.
So in that situation, since the actuator is extended, we could just drive it inward until it hits its limit switch.
That's right, we absolutely could. We're going to go ahead and click run in now, and we're going to see the actuator run all the way back. Great.
And he set a 100 millimeter virtual limit in there. We'll show you traveling only to 100 millimeters.
Now notice we told it to move all the way out. That's the same as applying an outward signal to the actuator, but it stopped at 100 millimeters because we said that's your entire range and you're not allowed to move outside of it. So if you were to look at the feedback right now from this actuator, since we set 0 to 10 volt analog, you would see it at a full 10 volts right now.
So this actuator is the IC Advanced. We do have IC Basic, which is similar to the platform, but it actually does not utilize the BusLink software.
That's right.
We have IC Parallel actuators, which you can adjust the parameters on BusLink. And there's actually one more tab at the bottom on the side here that you can select the number of actuators that you want in your parallel system, selectable from 2 to 8. But with the IC Parallel, you are not actually able to use positioning feedback, so that aspect of the menu is taken away.
That's right. The positioning feedback in IC Parallel is actually reserved for the parallel functionality to speak between the actuators and communicate that signal. Those leads are actually taken out. Along the top of the screen, you also have the options for monitoring and service. And we're going to start with monitoring first, where we get a real-time view of just up-to-date current levels, voltage consumption, and the position of the actuator, noted by the green, red, and blue lines. With this real-time view, we're going to go ahead and do a step in real quick and see what kind of information we learn about the actuator and the current it's consuming over time.
So we have the option to take a snapshot of the graph that we just created. In this, you can see certain things like the current spike and startup, and then we have, in this situation, relatively flat current consumption. You can use this program and snapshot feature to say if you are experiencing a change in the load over the stroke length, you'll see a spike there.
And that can tell you, like, wait, what position is it running into that extra load? It might be really nice, especially when running diagnostics on a machine that maybe you're seeing a little bit higher force than usual on, and you want to figure out where. So we're going to go ahead and click Stop now, and we're going to go over to the Service menu, where we can see a new tab on the left side here called Counters. And this just basically keeps a full lifetime tracking of what the actuator's seen in its life. It gives you a good idea of what your duty cycle's been, how many times it's been run out or in. It gives you a lot of different features that you might want to know, like the actuator's temperature over life. These are really good if you're just curious, what's this actuator been seeing and how, rough has this environment been on it. It's just a really great diagnostics tool for servicing the actuator itself.
Probably one of the most important parameters in there is reason for last unintended stop. If your actuator has gone to like an overload, current overload, and stops, throws an error, then you can actually open up the program and see which one is caused that problem. We're always adding new features to our IC platform and BusLink software.
Be sure to check out the BusLink user guide at LINAK.com. In there you'll find a lot of information about this video itself, about how we set it up, how to connect it in a step-by-step process, as well as each of the little features that we talked about in the video. So thanks for joining us for this LINAK Anatomy of Actuation video, and be sure to check back next time. We're going to have more of these coming soon.
Stay tuned. Did I say that last time? Stay tuned? Or
It's all
something
good.
like that?
It's all good. Stay tuned's cool.